Hi there, this is Mrs. Tellas. We're going to finish up 7.6 today. We're still going to be factoring trinomials that have a number other than 1 up in front for A. We'll be using guess and check and grouping like we did on Monday. And today we're going to add in a step that's in front of the factoring, the main factoring that we've been learning about, taking out the GCF. So we're going to combine what we did in 7.4 and what we did yesterday in 7.6, and we're going to do it all in the same problem. So let's give this a try. Here we go. All right, so connection to prior learning. So it says to factor and solve. Okay, notice that it's set equal to 0. That's a dead giveaway that we're going to solve. All right, so I look here, keep making a t. I need to multiply a times c. So 4 times 3 is 12. So we're looking for factors of 12 that give us a sum of 13. Well, 1 times 12 equals 12. And if I add them, I get 13. So I find those right away. So I'm going to guess and check here. So I want the inside, when I multiply these two, I want them to multiply out to 1x and the outside to equal 12x. Remember, I'm taking those from the factors we find in the table. So the 3 is going to be the easier of the two. The only options I have for 3 are 1 times 3 to multiply. So I'm going to put the 3 back here and the 1 here. And the reason I did that is because if I put 1 here, if I put 3 here, 3 times nothing is going to give me 1x. So that doesn't work. So that piece of the puzzle won't fit there. So my options over here for 4 are 1 times 4 and 2 times 2. Well, if I need the middle to be 1x, doesn't this have to be 1x? Which means it's this one. And if I put that 4x here, 4x times 3, that's 12x. Notice that both of your signs are positive. So these are both plus. So now we can set both of the binomials equal to 0. 4x plus 1 equals 0. And I'm going to drop that 1. 1x plus 3 equals 0. So this one I'm subtracting 3 on both sides. I'm getting negative 3. And on the other one, it's a two-step equation. So I'm going to subtract 1 on both sides and divide by 4. So that solution is negative 1/4. Or if you want to put it in the calculator, you could get a decimal. Negative 1 divided by 4 would give you negative 0.25. All right, so here is the new learning. We were going to factor exactly like we did yesterday. I'm going to be going back and forth from guess and check and grouping. We're back and forth between them. I'm a guess and checker. It's my nature to be like that. So I have to kind of remember to do grouping. So if I skip a grouping turn, my apologies in advance. All right, so if the coefficients have a greatest common factor, you got to factor it out first. So what that means is we look at all 3 of the numbers. And if there's the number that we can divide it out of each of those, we need to do that before we start guessing and checking or grouping, whichever you prefer your method. Well, as I look at 4 and 24 and 32, I notice that 2 would come out, but so would 4, and 4 is bigger, so I'm going to go with 4. So we're going to put a 4 out front. So we're going to be dividing each of these by 4. So x squared plus 6x plus 8. And we're just factoring here. We're not solving. There's no equals 0. There's no directions to solve. So now I'm looking for factors of 8 that give me a sum or a difference of 6. And it's going to be a sum because they're both plus. So 1 times 8 is 9 if I add them. And 2 times 4 is 6 if I add them. So it's 2 times 4. Since this has a 1 here, I could have multiplied 1 and 8. I didn't need to. This middle trinomial is from section 7.5. We weren't really having to do the guess and check as much. As soon as we figured out in the table, we knew what the binomials were. So this is x plus 2 coming from the table, and x plus 4 coming from the table as well right here. So this is my answer. And if I wanted to check it, I could FOIL the binomials and then distribute the 4, and it would come out the same as it started. But I don't want to do that. It's like I'm factoring is kind of like unfoiling, and if I want to check to see if it's right, I could refoil it. But I don't want to do that. I want to that'll put it back the way it started. Then I'll be like I didn't even solve it. But if I wanted to check it, I could. All right, let's do number 2. So if we look at number 2, We're looking for a GCF, and we're just factoring. We're not solving. There's no equals 0. So I'm thinking maybe 2. Let's see. 12 divided by 2, 46 divided by 2. Yep, 14 divided by 2. Let's divide all of them by 2. See what we come up with. Whoop. There we go. So divide by 2 for each. So that's 6x squared plus 23x plus 7. So we are looking for factors of 42 that give us a sum of 23. And I know it's a sum because they're both plus. Okay, so 1 times 42 adds to 43. 2 times 21, if I add them, I get 23. That's it. So I'm going to make these middle one 2x and the outside ones 21x. And I'm going to start with this 7 because 7's prime. There's only 2 factors, 1 times 7. And I'm going to finagle them in there. So I can't put the 7 here because 7 times nothing gives me 2x. So I'm going to put the 7 in the back position and the 1 here. So I have to think, okay, I need 1 times something that gives me 2x. Well, I think it's 2x. And I need 7 times something that'll give me 21x. Well, that's 3x. And 3x times 2x is 6x squared. So I've got it. I just need my plus signs in there because those are both plus, and I'm in good shape here. I've got this nice and factored. This is the answer. And again, if I wanted to check, I could FOIL it and then distribute the 2 when I'm done. All right, number 3. Again, it just says factor. There's no solving. You can tell because it doesn't say solve. And also, it's not set equal to 0. Let's group this one. So 15 times 6. 120 maybe? Let's check. 15 times 6 is 90. Ooh, guys, a little off there. Actually, before I do that, do you notice that it has a GCF? Yeah, let's try that GCF before we do that 90 there. Okay, I'm thinking 3 maybe. Yeah, let's take a 3 out and see what we're left with. So if we divide 3 here, here, and here, that'd be 5x squared plus 11x plus 2. Oh, this problem just got a whole lot easier. All right, so we need factors of 5 times 2, which is 10, that give us a sum of 11. So that's just 10 times 1. That's our first try, and we got it on the first try. So now we're going to factor it. So I'll make the inside 1x and the outsides 10x. They're both prime, so we'll put 5x here and 1x here. The only options are 1 times 2. So 1x, to get 1x, I'm going to have to multiply by 1. And if I multiply 5x times something, I've got to get 10x, so that's got to be 2. 1 times 2 is 2. Everything's plus, because they're both plus. So this is the factored form right here. Very nice job. All right, number 4. Okay, number 4 is a tricky one. Notice that it starts with a negative 12. None of the other ones have started with a negative. So when we pull the GCF out, we're going to pull it out as a negative to make that x squared positive. We want that x squared, or whatever letter it is, variable it is, we want that to be a positive number. So let's divide all 3 of them by negative 2. That will change them to positive, or especially this front one. We don't want that x squared to be negative. So that leaves me with 6x squared plus 13x plus 5. Okay, so we need factors of 30 because I'm multiplying 6 times 5. That will give us 13. So 1 times 30, when I add them, that's 31. That's not it. 2 times 15, when I add them, that's 17. That's not it. 3 times 10, when I add them, that's 13. There it is, right there. And notice there aren't any negatives inside the parentheses, so I'm not worried about this negative 2, just inside the parentheses. So let's group this one. So I drop down the negative 2, and it's really not really part of the grouping. I just keep dropping it down in the math. So I'm going to rewrite this 13x as 3x and 10x from the table. So 6x squared plus 3x plus 10x plus 5. We'll make that a bracket. So we're looking for a GCF of these two. I drop down that -2, put my bracket. So these two have a GCF of 3x. So that inside, if I divide both of these by 3x, leaves me with 2x plus 1. And then these two back here have a GCF of positive 5. So that also leaves me with 2x plus 1. So since these are matching, I know I'm right. So that's one of the binomials. And then the other binomial comes from the two GCFs that I took out when I was grouping. So that's 3x plus 5. And I don't want to forget that GCF. It just keeps dropping down here, here, and then here in the answer. This is the answer. Okay, we're going to guess and check this other one. So looking for a GCF, let's see, I can't divide 3 by 2. I can't divide 4 by 3. Yeah, I don't see anything else. So this one doesn't have a GCF. So this could have been in yesterday's notes. So we are looking for factors of -45 that give us positive 4. So 1 times 45 is 46 if I add and 44 if I subtract. Ooh, that line is really close. Let's scooch that over. Come on. Okay, I was having technical difficulties with my pen. I think it's better now. Okay, so 1 times 45, if I add them, is 45. If I subtract them, it's 44. Okay, so 2 won't go in, 3. 3 times 15, if I add them, is 18. If I subtract them, is 12. That doesn't work. 5 times 9. If I add them, that's 14. If I subtract them, it's 4. It has to be this, but I need some signs because it's -45, not positive 45. So I want it to add up to 4, positive 4, which means that the bigger one has to be positive and the smaller factor has to be negative. So we're going to put the negative right here. -5 times 9 is -45. And if I add them, I get 4. So these are the two factors I want. So I'm going to guess and check this. And it doesn't have a GCF, so there's nothing there to drop down. So we'll make the middle -5x, and we'll make the bottom 9x. Okay, 3x squared. I don't have much of a choice. This is 3x and x. 15, I have 1 times 15 or 3 times 5. But if you notice, I have an x here, and I need this to be -5x. So we're going to have to put -5 here, which means it's this one, and 3 here. And that's going to be a plus. Let's see if it works. -5 times x is -5x. That's true. 3x times positive 3 is 9x. That's true. This is the factored form that we're looking for. All right. Number 6. Notice that it changed a little. Now it doesn't just say factor anymore. It says factor, then solve. And then it says don't forget to check for a GCF. So we have to check for a GCF every single time. Sometimes it has it, sometimes it doesn't. But that's something that we have to look for every time. So 8 and 22 and 15. Let's see. 2 would work for 8 and 22, but not 15. 3 only works for 15. And I think that's about it. I don't think it has a GCF. So we're just going to factor like normal without the GCF. So 8 times 15. So 8 times 15 is 120. So I'm looking for factors of 120 that give me 22. And since they're both positive, I know that the signs inside are going to be plus. So I don't have to do the minus that I usually do over here. I can just plus everything. So 1 times 120 is 121. 2 times 60 is 62 when I add them. 3 times 40 is 43. I'm getting closer. I'm still not there yet. 4 times 30 is 34. 5 times, let's see, 24, when I add them, is 29. If I divide by 6, 6 times 20 is 26. I'm getting closer. How about 8, maybe? 8 and 15. So 8 plus 15 is 20. 8 plus 15 is 23. We got anything else here? Let's see. How about 10? 10 times 12. Ah, there it is. It adds up to 22. There it is. Okay, so we need one of these to be 10x, and then the other, the outside two, to be 12x. Let's see, 8, I've got some choices here. 8, I could either use 1 times 8, or I could use 2 times 4. So let's see what we got here. Let's just, let's go with 2 and 4. And we may have to move them. You never know. So let's try 2x here and 4x here. Okay, and as I look at that, I notice I could do 2x times something to get me 12x, but 4x times nothing is 10. So I'm going to switch those. Let's switch those to 4x and 2x and see if that puzzle will fit like that better. So 4x, that would make this one 3, and 2x. Oh yeah, that one works a lot better. Okay, so 5 times 2x is 10, and 4x times 3 is 12x. So it works under on the bottom side. Let's make sure. These two multiply to 8x squared, and these two multiply to 15. That's perfect. We did it. We made the puzzle fit together. Okay, so now we got to set them both equal to 0 because it says equal 0 and the directions I solve. I'm going to do it over here because I'm out of room. So 4x plus 5 equals 0. So I subtract 5 on both sides and divide by 4. So negative 5 over 4 is my first solution. And the other one, 2x plus 3. First I subtract 3 on both sides, and then I divide 2. So negative 3 over 2, or negative 1.5 if you're a decimal person. Let's try number 7. Notice that the directions didn't change. It still says factor and solve, but we're supposed to be sitting equal to 0, and currently the equation is sitting equal to negative 10. We need to move the negative 10 to the other side where x squared is positive. So I'm going to make a t and move that. So if you're in my class, you know how you move a negative 10 or a minus 10 is to do the opposite, which is add 10. So 6x squared plus 32x plus 10 equals 0. All right, let's take a look. Do we have a GCF? Well, 2 will come out of all of them. 3 doesn't work. I think it's 2. So let's divide 2 by each of those terms. So divide 2, divide 2, divide 2. So 3x squared plus 16x plus 5. So we are looking for factors of 15 that give us 16. Well, 1 times 15 fits the bill right away. Okay, so let's go ahead and factor. Notice I pull that GCF straight down. So I'm going to make the inside 1x and the outside 15x. So for 1x, I think 1x is going to have to go in. I think it's going to have to be like that. 3x and 1x are my only choices. And then 5 and 1 are my choices for 5. So 3x times 5, 1. Let's see if that works. Everything's plus. So 3x times 5 is 15x. That one works. And 1 times 1x is 1x. That's the answer. Right, that's the factor form. Now I have to solve. So everything that has an x has to be set equal to 0. So the 2, although part of the factored form, does not get set equal to x because it doesn't have one, or equal to 0. It doesn't have an x. So 3x plus 1 equals 0, and x plus 5 equals 0. So let's subtract 1 and divide 3. So my first solution is negative 1/3, and my second one is negative 5. All right, number 8. If you haven't tried one by yourself yet, I would like you to push pause and give this one a try. Do not forget to check for a GCF. All right, looks like the GCF is 3. So I'm going to divide all of the trinomial by 3. So that's 10q squared plus 9q plus 2. Okay, so I'm looking for factors of 20. 10 times 2. They give me a positive 9. Notice everything's plus, so I'm just doing their sums. So 1 times 20 is 21. That doesn't work. 2 times 10 when I add them is 12. That doesn't work. 4 times 5 is 9. There it is. Okay, so let's rewrite it. Drop the 3. So we want one of them to be 4x. So we'll go inside with the 4x. And the outside is going to be 5x. So let's give this a try. So for 10, I could maybe use 1 times 10, or I could use 2 times 5. Looking at what I have here, I can't multiply anything with 10 and get either of these. So it's got to be this bottom one. So let's do 5x here because of the 5x, and 2x here. And then over here, I've got 1 times 2 for sure. That's the only possibility there is. So if I want 4x from these two, that would have to be a positive 2. And this would have to be a positive 1. So let's check it to see if it works. Make the puzzle pieces fit. So 2 times 2x is 4x. That works. And 5x times positive 1 is 5x. That works as well. So it's factored correctly. Now I set both of the parentheses or anything with an x equal to 0. The 3 doesn't have an x, so I don't set that equal to 0. So 5x plus 2 equals 0, and 2x plus 1 equals 0. So these are both two-step equations. So on this first one, I'm going to subtract 2, and then I'm going to divide 5. So I get negative 2/5. And on the second, I subtract 1 and divide 2, which gives me negative 1/2. So I got 2 fractions. Fractions are completely fine. If you want to put them in as decimals, you can, but it is not necessary. All right, last one, tabletop. Okay, tabletop has an area of 18x squared plus 69x plus 60. The width of the rectangle is 3x plus 4. What is the length? So we have a rectangular table. It says that the area is 18x squared plus 69x plus 60, and that the width, which is usually the short side, is 3x plus 4. And we're looking for the long side. We're looking for this side. So we want to know when we multiply the length times 3x plus 4, do we get 18x squared plus 69x plus 60? So there's a couple things you could do here. You could kind of play with it over here and figure out what you could multiply. Here, let's do it that way. Or we could factor it. We'll do it both ways. All right, so if I make this bigger, and I want to multiply this piece right here, this front, and this one, like I'm foiling it. So something times something is going to give me 18x squared. What would have to go here? What times 3 gives me 18? Well, that's 6. 6x because it's x squared. And then if I do the same thing for the back here. So I want to do something times 4, and I want that to equal 60. So I think that's 15. 15 times 4 gives me 60. Okay, so I could kind of do it that way. I multiplied these two and got this one, the 15 and the 4, and I multiplied these two and got this one. If I wanted to check it, I could FOIL it. I could totally FOIL it. Okay, or I could factor it. I kind of like this guess and check way better, just kind of playing with it and trying to get it to fit. But we can make sure that it's true by foiling. So 6x times 3x is 18x squared. 6x times positive 4 is plus 24x. 15 times 3x is 45x. And 15 times 4 is 60. So if I add those two middle terms, yeah, I get the area exactly. So yeah, the width here is 6x plus 15. Okay, that was a long one. All right, so your assignment is on it's on the same page as Monday. It's page 395, 3 to 8, 23, 25 through 32, and 33A. If you need help, I'm online 11 to 12 every single day, Monday through Friday. Feel free to get on there. I'm happy to work problems with you, or if you just want to practice, whatever you'd like to do, I'm happy to do that with you. And it's on Big Ideas, just like it always is. So take care. Talk to you later. Bye-bye.